Here we have another double integral that is posed in an order that you can't integrate with respect to. First, this is dxdy, but the antiderivative of the inside can't be done in terms of x first. And so we identify the region correctly. Because x is first, that means that x's go between the square root of y and 1, and y's go between 0 and 1. We have to correctly identify the region based off of this. If x is equal to the square root of y, that's more commonly known as y equals x squared. So that's a parabola. And then x equals 1 is a vertical line. Now dxdy is done with a rectangle who is horizontal and moved vertically. And so the lower bound is the square root of y, and the upper bound is the x equals 1. And so that's going to be your parabola, y equals x squared, and then we have x equals 1, and so the region must look like this. The x's go from root y to 1. The y's go from 0 to 1. And so the low bound inside is x equal root y, and the upper bound inside is x equals 1. And these are inside, and then we have the lower bound outside and the upper bound outside. Alright, so we have correctly identified the region. We have these outside bounds, we have these inside bounds, and it's necessary to go through all this. Okay, I provide you with this structure so to help you be able to do it on your own, and so just please do your best to follow the structure. If you're ever worried about what the bounds are, I want you to go through this process. Now we need to switch the bounds. Switch the order of integration, that is. Same region, but now instead of dx dy, we have to do it as dy dx. dy dx is done with a vertical rectangle that is moved horizontally. I put the circles at the end of the rectangle so that you can figure out the upper bound and the lower bound on the inside. And so they have to be in terms of y equals. The lower bound, as you move this throughout the region, is going to be y equals 0, while the upper bound is going to be the parabola y equals x squared. Then this gets moved from x equals 0 to x equals 1. So you have outside bounds of 0 and 1, inside bounds of 0 and x squared. This is a dy dx integral, and the integrand I'm going to rewrite as e to the x squared over x cubed, and that's going to be times y. I separate it like that on purpose so that you can recognize how to find the antiderivative perhaps in an easier way. It's respect to y. And so all of this e to the x squared over x cubed, that's all constant in y. And so you just copy that part down. E to the x squared over x cubed, and you integrate y and get y squared over 2. And it's that term in which you plug in the y equals 0 and the y equal x squared. You still have this outside integral from 0 to 1. It is a dx integral. And we put in the y equals x squared. We put in the y equals 0. And we have the inside integral done. It is x squared over 2 minus 0. And so that's x to the 4th over 2. We are going to be then 0 to 1, e to the x squared over x cubed, and now we have this x to the 4th over 2. And we can simplify it. It works out perfectly for us that this x cubed and this x squared cancel to just give you an x. Why is that so good? Because now you can integrate. You have x e to the x squared, and you are integrating from 0 to 1. When you do a u sub and let u be x squared, du is 2x dx. Did I forget my over 2? I'm sorry, I forgot my over 2. I forgot my 1/2. Let's pull that out. If u is equal to x squared, then du is 2x dx. Your job is to replace x dx, and so we get half of du replacing the x dx. So you have the 1/2 that's on the outside, and then the x and the dx combined to be replaced by 1/2 of du, and then we have e to the u. That's going to lead to 1/4 of e to the u. Now, we could go back into x squared and have 1/4 e to the x squared, and we evaluate that with the original bounds of 0 and 1. Or we could have done a limit switch, and what happens is it happens to also be from 0 to 1 when we switch the bounds. So we have e to the 1, and then e to the 0, and then the 1/4 on the outside as our answer. And that corresponds to letter A. Okay? And so be able to execute the limit switch. When you correctly identify the region, you take these bounds and you put them as the inequalities here, and then you have to focus your attention on the actual function x equal root y. Translate to something that you know, be able to graph that, and know exactly what the region is, so you can then switch it. Alright, great.